Here's another good ratio that you might use in your car. 40 miles per hour. Aha! Didn't you say that a ratio was a relationship between two numbers? But 40 miles per hour is just one number. Looks like someone's got some explaining to do. Actually, there are two numbers. Do you remember how any number can be written like a fraction just by writing 1 as the bottom number? Well, 40 miles per hour is the ratio 40 miles per 1 hour. Well, I guess you have an answer for everything, don't you? 40 miles per 1 hour is a type of ratio that we call a rate. A rate is just a ratio that usually involves a period of time. Here are some common examples of rates. 10 meters per second, $12 per hour, 3 meals per day, 50 games per year. Notice that the bottom numbers in each of these ratios relate to a period of time. Seconds, hours, days, years. And that's why we call them a rate. Alright, so that's simple enough. But you might be wondering, why are the bottom numbers of all these rates 1? Couldn't you have a rate like 90 meters per 9 seconds? Or $60 per 5 hours? We sure could. But most of the time, when we have rates like that, we want to convert them into an equivalent rate that has 1 as the bottom number. And that's because whenever the bottom number represents only one unit of time, like 1 hour or 1 day, it makes comparing different rates much easier. For example, imagine two cars driving at two different rates. The first car's rate is 120 miles per 3 hours, and the second car's rate is 150 miles per 5 hours. Which car is going faster? Well, it's not all that easy to tell when the rates have different bottom numbers. Fortunately, it's really easy to change a rate so that it has 1 as the bottom number. All you have to do is divide the top number by the bottom number. The answer you get is the top number of the new equivalent rate, and the bottom number is just 1. Rates like this are called unit rates because unit means 1. Alright, let's convert the rates of speed for our two cars into unit rates so that we can compare them easily. The first car's rate was 120 miles per 3 hours. So if we take 120 and divide it by 3, we get 40. That means that the unit rate for the first car is 40 miles per hour. The second car's rate was 150 miles per 5 hours. So if we divide 150 by 5, we get 30. So the unit rate for the second car is 30 miles per hour. And now you can easily tell that the first car is going faster. And you can tell why unit rates are so.
Thanks, Mr. Math Antics, for really helping us see the difference between ratio and rate and giving some visuals of what a rate is. Let's write down a definition for rate, 7th graders. Find your 6.2 notes. We're going to be in that first chunk, and we can refer to this definition anytime we draw a blank on what a rate is. So a rate is the relationship between two quantities that have different units. And as Mr. Math Antics pointed out, rates refer a lot of times to the concept of time. A unit rate is a special type of rate with a denominator of 1. Unit rates are really nice to compare with, like in the Mini Cooper example. Like in the Mini Coupe example Mr. Math Antics gave. To find the unit rate, you divide. Make sure this part is filled in your 6.2 notes. Let's get ready to go to the next part and practice working with rates. Question, why is it important that we write and interpret rates correctly? So basically, why is it important that we set up a rate correctly? Let's use this problem as an example. An Olympic athlete's heart beats 135 times in 3 minutes. First of all, what two things are we comparing above? We're comparing heartbeats, 135, to minutes, 3 minutes. So let's write that using a rate in the order that you see it here. Heartbeats on top, minutes on bottom. So it would be 135 beats for every 3 minutes. I could also say 135 beats per 3 minutes. Notice how I have this written in fraction form. Now let's find the unit rate. Unit rate, remember, has a denominator of 1. So I'm going to get that prepped. We want to know how many beats are going to be in 1 minute. So I have my rate over here set up. Now we need to figure that out. And like Mr. Math Antics pointed out, we really just take from our rate 1 here, we take 135 and divide it by 3. But this is what it looks like also. How do we go from 3 to 1? We divide by 3. So I'm going to take 135 and divide it by 3. Fill that in your notes. If you don't have a calculator out, pause the video and go get one. If you do, then let's take 135 and divide it by 3. I get 45. Let's interpret this unit rate that you see in front of you. What does it mean? Think about how Mr. Math Antics described the vehicle problem in his video. Well, 45 beats, what are words that you can say to represent this fraction bar? For every, for each, per. The heart beats 45 times for every minute. There's an interpretation of that unit rate. Pause the video to write that down. Now let's write this rate differently. Let's switch and put minutes on top, beats on bottom. Because remember, we're trying to figure out our question, on the left-hand side. Why is it important that we write and interpret rates correctly? We're just going to switch now and put minutes on top, heartbeat on bottom. So 3 minutes for every 135 beats. Let's find the unit rate of that rate. So I want to know how many minutes for 1 heartbeat. Again, we would just take 3 and divide it by 135 like Mr. Math Antics pointed out, or I could show it like this. How am I going from 135 to 1? I'm dividing by 135. So I'm going to take 3 and divide it by 135. Pause the video so that you can get that down in your notes. If you're ready, take 3 and divide it by 135. You get a decimal answer, don't you? Let's round to the nearest hundredth. So it would be about 2/100ths of a minute for every 1 beat. That would be a way that you could interpret that rate. What would be another way that you could interpret that rate? We're comparing minutes to beats. I said every 2/100ths of a minute, your heart beats 1 time. Go ahead and write that one down. Graders, which one of these interpretations do you understand the best? The first one, the heart beats 45 times for every minute. Do you think you could use that rate to figure out how many heartbeats you'd have in 10 minutes? Yeah? How about that second interpretation? Does your brain comprehend that as easily? Every 2/100ths of a minute, your heart beats 1 time. Not as clearly. I think, and maybe you'll agree with me on this, the one that my brain comprehends the best is our first setup here. And that's because time is on the bottom. And that's something Mr. Math Antics talked about. We're comparing something to time, and we call that a rate. So it's really nice to have time on bottom. It helps us interpret the rate a little bit easier. Let's look at another example. Here we have 5 gallons of gas cost $12.90. What am I comparing in this problem? I'm comparing gallons, we have 5 of them, to cost, which is $12.90. Let's write that in fraction form as a rate. They're comparing different units. That is a rate. So let's put 5 gallons on top, and we're comparing that to $12.90. Now let's find the unit rate. I want a denominator of 1, so that means I'm figuring out how many gallons for $1. Well, we would just take 5 and divide it by $12.90, or I can show it like this. How am I going from $12.90 to $1? I'm dividing by $12.90. So take 5 and divide it by $12.90. 5 divided by $12.90. What do you get? A decimal, right? Let's round to the tenths place this time. We're practicing on rounding to different places. So I get about 4/10 gallon for every dollar. 4/10 gallon per $1. Another way I could say that. How would you interpret that? About, since I had to round, about 4/10 a gallon per dollar. That's one way that you can interpret that rate. Is it the only way? No. Go ahead and write that one down. Pause the video. Let's set up this rate another way. Let's just flip it and put cost on top, gallons on bottom. I would be comparing $12.90 to 5 gallons. Now let's write the unit rate. Remember, unit rate has a denominator of 1. So I want to know what's the cost for 1 gallon. Well, we're going to divide by 5. Take $12.90 and divide by 5. What do you get? We don't have to round, do we? Since it's referring to money and money goes out to the hundredths place, $2.58. How would you interpret the unit rate 2 there? What does that mean? Well, one way I think about it is it's going to cost $2.58 for every gallon of gas. Why is it important that we interpret rates correctly? It helps us understand the situation, doesn't it? Which one of these rates, rate 1, rate 2, makes the most sense in your mind? Gallons on top or where money is on top? I think you would agree with me that my mind interprets rate 2 here the best. $2.58 for every gallon of gas I use. If I'm going to use 2 gallons of gas, I'm going to take $2.58 and times it by 2. That's going to cost me $5.16. I could use this interpretation and build upon that. So what was the point of this, Ms. Kluber? Well, the point is to answer that question of why is it important to interpret rates correctly? We want to be able to use the rates to help us solve problems. So some things that are important to note here is what goes on top and what goes on bottom. On the left-hand side of your notes, next to this chunk, let's write this in. Money on top, just like we interpreted rate 2 the best here, right? And then time on bottom. Like in our first example, when we were referring to heartbeats per minute, it was easier to comprehend when the time was on the bottom. So when we're setting up rates, let's make sure that we put money on top, write that in on the left-hand side. Time on bottom. Let's build upon this. Pause the video and finish writing anything that you need to. I am not a huge fan of Mountain Dew, but I bet some of you are. And the point that I'm going to try and make with this problem is deeper than the product here. Find the unit price of buying a 24-pack of Mountain Dew at Walmart. First of all, there is two words that stand out to me. Unit price. That's referring to how much one of these cans costs. It's asking me to find the unit rate. What did we just write down on the left-hand side? Whenever money is involved and it's a rate, where do we want money to go? Top or bottom? Top. So how much does a 24-pack of Mountain Dew cost at Walmart? Look down here underneath my picture. $6.98. So let's set up that unit rate. Cost on top. So $6.98 for every 24 cans, because this is a 24-pack. Let's find the unit price. Meaning, what does it cost for 1 can? Well, when we find the unit rate, we divide the top by the bottom. Or you can set it up like this. 24, how am I getting to 1? Divided by 24. $6.98, divide that by 24. And since we're dealing with money, we want to round to the hundredths place if we need to. So $6.98 divided by 24, round to the hundredths place. About how much does it cost per can? 29 cents, rounding to the hundredths place. So it's 29 cents per can. Make sure you have what's in front of you in your notes, because I'm going to ask you another question. Make you think a little bit here. Here at school, it costs 75 cents per can to buy pop. What's the better buy? Buying the 24-pack or buying a can of Mountain Dew here at school? 75 cents per can, that's a unit rate. Notice I have the unit rate in a math sentence up here. Notice it's in words down here. Where does it cost less per can? Buying from the store instead of buying here at school. Unit price, comparing prices. Rates are really helpful with that. And people look for ways to save money. Here would be a way that you can save money. Let's go to example 4. You travel 250 miles in 4.5 hours. About how fast are you driving? Just a reminder, unit rates are helpful. What are we comparing to what in this problem? We're comparing miles, 250 of them, to hours. Do you remember where time goes in a rate? Time goes on bottom. So let's set up this rate. We're comparing different units, miles and hours. Miles measures distance, hours measures time. They're not the same units. Time goes on bottom. We wrote that as a little note on the left-hand side of our notes. So about how fast are you driving? Well, let's figure out our miles per hour. Let's set up our unit rate. Pause the video at any time if I'm clicking through and it's too fast for you to write along with me. We just take 250 and divide it by 4, or it can look like this. How am I going from 4 to 1? Think of your equivalent fraction knowledge. Dividing by 4. So 250 divided by 4, that's going to give me 62.5 miles for every hour. Or you could say I'm driving about 63 miles per hour. At that rate, about how many miles will you travel in 7 hours? Could we use our unit rate here of miles per hour to help us figure out how far we will have traveled in 7 hours? Yeah! You don't have to write this table down, but just look, this is another way to see rates. It's 62.5 miles for every hour. So if I wanted to figure out how far I'll drive in 2 hours, what would I do? Well, you could add 62.5 plus 62.5, or repeated addition is the same as multiplying. You could times by 2 and you'd get 125. What about if I wanted to know 3 hours? Because my question says I need to know how far I traveled in 7 hours. Well, you'd either add 62.5 or you would take 62.5 and times it by 3 and you'd get 187.5 miles. How would I get to 4 hours? We'll add 62.5 or take 62.5 and times it by 4. And I could keep going and I would see that in 7 hours, I will have traveled almost 438 miles. This is repeated addition, isn't it? This table is showing you every time I move to the next box, I'm adding 62.5, adding 62.5. So a faster way to get to my answer here is just to recognize that I can use that unit rate, which got me 62.5 miles, and I can times that by 7. Unit rates are really helpful when it comes to solving problems and comparing. Let's look at the last example. With some species of bamboo, you can actually see them grow. You could observe 30 centimeters of growth in just a third of a day. Don't be intimidated because there's a fraction there. At what rate does this bamboo grow? What are we comparing in this problem? 30 centimeters of growth. And how long it takes? Day. That's referring to time, right? Day is a measurement of time. So at what rate does this bamboo grow? Well, let's set up our rate. 30 centimeters for every a third of a day. We want to know how much does it grow in 1 day. Pause the video if you need to get that down, if I'm clicking too quickly. How am I going from 1/3 to 1? Or remember, you just take 30 and divide it by 1/3. Mr. Math Antics showed you that in his video. I would divide by a third, so 30 divided by a third. You can use your calculator or write it out in your paper. Keep 30, change division to multiplication, and flip, find the reciprocal of 1/3, which would just be 3/1. So really 30 times 3 gets me my answer, and that would be what? 90. Interpret that unit rate right there. 90 centimeters for every 1 day that bamboo is growing. We can take that a step further. How tall will the bamboo be in 1 year? Now what's different here? I know that it grows 90 centimeters in 1 day. You don't have to write this table down. How much would it grow in 2 days? Well, I would go 90 plus 90 or 90 times 2, which is 180. But down here it's asking for a year. I need to recognize that my units, I have day up here and year here. Let's change year to represent days. I have to be working with like units when they're across from each other in my rates here. Do you see that? Day is next to day, centimeter is next to centimeter. So let's change 1 year. How many days is that? It's not a leap year. 365. So I could extend my table all the way to 365, or I could just recognize that I'm going to take 90 centimeters, because that's what it grows every day, and times that by 365, because that's how many days are in a year. And that's going to give me 32,850 centimeters. So the thing with this problem, 7th graders, is, do you see how in my first part A here, my unit was day, and I was still maintaining that unit, but all of a sudden it switched to year. So I needed to convert years back into day. That can be a little tricky. So make sure, here's a quick way to just say it, and hopefully it'll help your brain comprehend it. When your rate is set up, you need to have your like units across from each other. We can't have day and year over here. Notice on the top we have centimeters and centimeters. So being mindful that my like units are across from each other. That's our lesson for today. I realize the note sheet is not completely done. That's because this is a 2-part lesson. Go ahead and add these few sentences to the summary box for your 6.2 notes. We'll add to it more tomorrow. Rates compare quantities that have different units. A unit rate is a special rate with a denominator of 1. Unit rates are nice to compare and use to calculate.